Good. Yeah, there we go.
Can you hear me now? Okay, slides are okay? Good. Okay. Then yeah.
Yep,
Hello.
they seem okay.
Let me go to the presentation. Okay. Hi, my name is Tobias Weyand, and together with my colleague Bingy, I'm going to present, or introduce the Landmark Recognition Challenge this year. And after this, we are going to hear from the winning teams. So this year, we organized the 4th Landmark Recognition Challenge already. Time flies. And the main novelty this year was, as Sue just introduced, we put the focus on fairness by sampling the data set in a more fair way. The challenge is wrapped up 10 days ago only, and we had a total runtime of 7 weeks. Unfortunately, this year we were not able to provide any prize money, but nevertheless, we had a pretty strong participation of 383 teams. So we were very happy to see that there's still a strong kind of academic and not only financial interest in our challenge. This challenge is closely related to the Landmark Retrieval Challenge, which is going to be presented in the second session of the workshop. The top teams overlap is actually quite high between the two because obviously methods can be shared. Okay, so first let me introduce the general problem of the challenge. So as it was in all previous years, the problem is given an image, recognize the landmark in it if there is any. So more concretely, it means that given a query image, the solution needs to predict a landmark label and then a confidence score in that label. And one particularity about the challenge is that not all the query images are actually landmarks. For example, the 2 images framed in red here, they are not landmarks. And for these, the submission is supposed to produce a low, ideally 0 confidence score, which puts an emphasis that approaches need to detect if an image is out of the query domain. The metric we used was micro average precision, or also called global average precision with 1 prediction per image. More details on that are in the GLDV2 paper. And I'd also like to note that this same metric, together with the distractor queries, was used in the Facebook image similarity challenge as well. Okay, so let's take a look at the actual code, at the actual challenge format. So like last year, we kept the format as a coding competition, which was hosted on the Kaggle platform. Coding competition means that participants can directly write the code that recognizes landmarks in a Kaggle notebook, which is like a Python notebook. And that directly runs on Kaggle servers as opposed to a person's workstation. Kaggle provides a very nice Python runtime. You can import pretty much any Python library you can think of for machine learning and computer vision. The participants are also allowed to upload their own models or any other pre-trained models, or upload any external data as long as that is disclosed to the other participants. Kaggle provides enough resources and also GPUs to run even sophisticated methods. So you could even run local feature retrieval, ransack, etc. Okay. So what data did we provide? Basically the data is split into 2 parts. There's development data and evaluation data. So the development data is used basically while people are coding and improving their models. And then when someone is ready to actually submit the data, then this development data is kind of swapped out for the evaluation data. And then the resulting score is posted on the Kaggle leaderboard. So the development data includes a training data set. In this case, we picked the GLDV2 train clean data set, which has been very successful for training landmark models. But as I said, participants can basically train on any data as long as they disclose what data they used. Then we also released the public test set of 10,000 images, which was only used to kind of mock the evaluation data. So this is not really used for scoring, but just so that people can kind of run on something that looks like the real data and see if their method works. And I would also like to note that none of this data needs to be downloaded to people's machines. So you don't need to have a strong computer to run any submission, but you can just use Kaggle's resources. Okay, now let's look at the evaluation data. So here we provided 10,000 images as a training set, or if you use retrieval, this becomes the index. And this was a subset of the GLDV2 clean. And then we provide a test set. Now this test set is sampled using the method that Zhu introduced earlier. So this is kind of fairly sampled. And here, 50% of that was for the so-called public leaderboard and 50% for the private leaderboard. So the public leaderboard is basically once someone submits and all and the participant's kernel has run, you get an instant feedback on the performance of your method, but only on half of the data. And then the actual score that is used to determine the winners is computed on the private data, on the held out data. Okay, with that, I would like to hand it over to my colleague Bingi, who is going to discuss the results of the challenge.
Thanks, Tobias. So, hello folks, this is Bingi. I'm going to introduce the metrics and conclusion of this year's Landmark Recognition Challenge. So this is the final results of the private dataset of the top 10 winning teams with their GAP score. So congratulations to all the winning teams. From the table, we can see all the top 10 teams achieve a GAP over 44%. So for the teams highlighted in orange, they are going to bring their presentation and share their solutions with us in the following session. Next one, please. So here is a histogram of the GAP score for all the participating teams this year compared with last year. So on the left side, we can see this year there is a big spark at around the GAP score of 0.22. So that comes from a popular kernel shared by one team and resubmitted by many other teams. But we can notice our winning teams were able to strongly distinguish themselves from the baseline by achieving a GAP score about twice as the baseline. And we see the top 16 teams achieved a GAP score over 40% here. And on the right side, last year we see an even stronger spark. So that comes from the baseline we shared. And also we noticed this year, in general, the GAP score is lower than last year. So that is because this year we have the fair dataset, so it will involve more landmarks from more regions, makes this challenge more difficult. And also this year, we released an evaluation dataset with the fairness constraints, but we didn't release the fair training dataset, so that becomes more challenging. The next one, please. So besides the GAP score, we also applied other two alternative metrics to the top 10 team solutions. So there is a GAP star here. So the GAP star is the same metrics as the GAP we used in the challenge, but only considering landmark-only queries. So here, the GAP star disregards the method's ability to distinguish landmark and non-landmark images. But it will only look at how the method works well at recognizing landmark queries. And then we also have another metrics, which is accuracy here, which means the top one accuracy for the landmark queries. So from this table, we can see all these numbers are quite consistent across all the metrics. And our winning teams were able to achieve top scores with regards of all the three metrics. That's very impressive, so we cannot wait to hear their presentations. Next one, please. So now let's conclude this year's Landmark Recognition Challenge. So we had a great time setting it up for the fourth time, and we hope you guys have fun competing. And we're happy to see very strong interest in this recognition challenge, even though we were not able to provide the cash prize this year. And this year, we are also excited working a step towards the fairness dataset. We were able to reduce the bias in the evaluation dataset. So right now, we are happy to open up the Q&A session. So meanwhile, may I ask the top teams in the recognition challenge to start preparing their presentation for the next session. So now we're happy to take questions.
Hello, this is Bo. Question: Do you guys expect to host another competition next year?
We are still thinking about that. Yeah, I can't give a concrete answer right now.
Okay, so it's possible. Okay, thanks.
Thank you. So maybe in the interest of time, we